and let's get started with introductions. Next slide, please. As a quick introduction, I'm your moderator, Mike Asham. I'm the Director of Application Sciences and Solutions at Opentrons. I come to you with a blend of biology and automation experience with a primary focus on genomics and molecular oncology. And our speaker today will be Catherine Lyles. Catherine is one of our esteemed application consulting engineers who earned her degree from Iowa State University, go Cyclones, and has an expansive biology and engineering career working for the U.S. Geological Survey, Monsanto, as well as TCAN. So thank you, Catherine. I'll turn it over to you.
All right. Good morning, everybody. Thank you for joining us for the webinar today. So today we'll talk about the Opentrons Protocol Designer as a way to generate protocols for the OT-2 without any sort of coding needed. So just a quick overview. So Opentrons really does take the philosophy that regardless of what skill level you have with automation, you should be able to use our robotic liquid handling platform. And so we've provided a software for every skill level to use our robot. So the first is our protocol designer, which is what we'll focus on today. But keep in mind that we also have our protocol library and then our Python API, which are also options in terms of creating protocols. We discussed the Python API in a previous webinar, so it's an excellent resource if that's your interest. And also keep in mind that there's also a fee-based option where an application engineer from the Opentrons team can build a customized protocol for your workflow. But for the purposes of today's presentation, we'll go over Protocol Designer, give you just a general overview. We'll talk about how to configure the software based on your hardware configuration. We'll build an example protocol, and then we'll round everything off with a few tips and tricks for using the GUI. All right, I'm going to get out of my slides here because I think the best way to show Protocol Designer is actually to do it live and do an actual walkthrough of the software. So let me transition my screens here. All right, so in order to access the Protocol Designer, you can simply go to opentrons.com. And in the upper right-hand portion of your screen, you'll see the option to click on Protocol Designer. Go ahead and click, and you'll be presented with the screen that you see here. So this is basically your blank canvas and your starting point for creating a protocol. To create a new protocol, you go to Create New. Here you can add the name of your protocol. So I'm going to call this protocol sample prep. Now I'm going to give information about the actual setup of my robot. So on my robot, I have a P300 multi-channel pipette that's mounted on the left, and that uses our 300 microliter tips. So I'll select that here in the dropdown. And I also have a P20 single channel, and that uses our 20 microliter tips, which I'll select here. This is also where I can add modules. So for the sake of examples for today's presentation, I'm going to select all of the modules that are offered by Opentrons. And I'm also going to select the generation of the module that I have connected. Once I've input this information, I click Save. And you can see that I'm given sort of a nice layout and overview of what's included on the system. So you can see my two pipettes now populate here. And also I'm given information on which modules are going to be on the deck and in what location on the deck those modules are placed. If I want to change the location of where those modules are placed, I simply click Edit and change that position. The software is also really intuitive and it guides you to the next step. So once you've gone through the actual configuration, you go to the bottom and click Continue to Liquids. So the liquid tab is meant to be a library of all of the liquids that you're going to use throughout the course of your protocol. So for the sake of this example, I'm just going to add a few. So I'm going to click New Liquid, and this sample name is just going to be sample. You can see that I can add a description here. So maybe my description is saliva. Maybe these are saliva samples. I also have the option down here to click serialize. So this will mean that every time I add a sample to the deck, it will be given the numeric indice of 1, 2, 3, etc., based on the number of samples that are added. Once I'm done with all of these parameters, I simply click save, and I can add my next liquid. So I'm going to add lysis buffer as my next liquid, and I can add a description here. Maybe it's the lot number, maybe it's the brand name, etc. Add whatever information you'd like here, or don't add any information at all. All right. And then the next step is just to go to the Design tab. The Design tab is really the powerhouse of the Protocol Designer software. So once I click on the Design tab, you can see that I have a nice graphical overview of the system. So this is meant to be the representation of the work table as it is in real life. So you can see in the back right corner, we have our waste location. And because I selected that we have all 3 modules on the deck, you can see that they populate on the work table automatically in the locations that we designated in our configuration. But of course, it's not just the tip boxes and the modules that make up a protocol. We also want to make sure that our starting deck state includes all of the labware that we're going to be using throughout the course of the protocol. So let's say, for instance, that the samples that I'm going to run are in a tube rack. I simply click on Add Labware, go to the tube rack section of the library, and select the tube rack and corresponding tubes that I have on my system. So for this example, I'm going to be using the 24-position rack that has Eppendorf 2 ml tubes loaded. I'm going to name my rack just for ease of use purposes. And I'm going to select the different positions in my rack where I have samples loaded. This could be in any pattern, row-wise, column-wise, or spread across the entire plate. And then I'm going to select that I have sample loaded in these tubes, and that, let's just say for example purposes, that I have 1,500 microliters loaded. Once I've selected the wells that contain the sample, you can see that I have a nice list located on the left that populates with the location of the tube, how much liquid is in that tube, and then the name given sample 1, sample 2, sample 3, sample 4, because we selected the serialized option for that liquid. Now, if I want a location for the lysis buffer, I'm going to select Add Labware again. And this time, instead of a tube rack, I'm going to select a reservoir. So I'm going to select the Nest 12-well reservoir. That's 15 milliliters per well. And I'm going to call this reagents. And then I'm going to add my lysis buffer to the first column of this trough. All right. So now I have the basics needed to start with a protocol. I'm going to also add a destination plate. I'll just add it to my temperature module, and I'll select my aluminum block that has my Nest plate loaded. And keep in mind, if you're not using any of the labware that you see located in the labware library, we do offer a custom labware creation tool so that you can use any of the labware that you have already existing in your protocols. So once you've created this nice starting deck state with all of your reagents, your samples, your tips, and plates, then you can actually get into building a protocol. So to do that, I'm going to go to Add Step. And when I click Add Step, there really are only 6 very easy to use simple parameters available. So the first is transfer, which is for transferring liquids from one location to the next. There's a mix function for mixing liquids, a pause function for pausing the protocol, and then one command for each of the modules. So a command to control the magnet, a command to control the temperature module, and a command to control the thermocycler. So let's start with the most commonly used command, which is the transfer command. So I'm going to select the transfer command, and I'm given this screen here that has a few drop downs that I need to include. So the first drop down is going to be the pipette that I want to use. So in this first step, I just want to add lysis buffer to my destination plate. So I'm going to use my 8-channel pipette. And let's say that I want to add 100 microliters of that buffer to my plate. Then I need to select where that buffer is coming from. So it's coming from my reagent trough. So I'm going to select reagents. And then I'm going to select my lysis buffer well. For my destination, I'm going to select my destination plate. And I had 24 samples that I loaded onto the deck. So I'm going to select the first 24 wells of my destination plate to distribute that lysis buffer. And then I'm going to click Save Selection. You can see that I also have options here for when I'm going to change my tips. So I can select before every aspiration, once at the start of the step, per source well and per destination well. Because I want to reuse my tips so that I can save on tip use, I'm going to select once at the start of step. I can also select the path of my pipette. The first option is to do a single transfer, where you aspirate once and then dispense multiple times across the plate. The second option is more of a pooling option, where you can aspirate multiple times and then dispense into one destination. And the final option is multi-dispense, where you aspirate once and dispense multiple times across the plate. I'm going to select this option because I'm just adding buffer to a clean destination plate. Once I select my multi-dispense option, there are additional options to include a disposal volume and a blowout location. I'm going to select my source well as my blowout location because I want to minimize the number of steps that go to my waste. And also there's no reason not to blow out my disposal volume back to my source because there's no risk of contamination. In addition to these sort of basic protocol steps, there's also an advanced settings tab that lives in the transfer. This is really where the customization occurs for a transfer step. So you can change things like the flow rate of the pipette. So this would be the aspiration speed or dispense speed. You can also change the tip position in the well. So you can select where you'd like to aspirate from and where you'd like to dispense to. You can also change the well order. So whether you want to go down a row or across a column, you can select that here. You can also add things like pre-wetting the tip, mixes, where you can select the volume you'd like to mix and the number of cycles that you'd like to mix with. You can select delays, tip touches, and the location in the well where you would like to do that tip touch. And you can also select air gaps. All of these parameters are built to enable our users to have the most accurate and precise liquid handling possible. So consider these when you're building in your liquid transfer steps for maybe things that don't behave like water. So you might make special considerations for things that are viscous or things that are organic solvents. Once you're done with each step, always remember to save. And then you'll see that the step populates here on the left. If we want to add another step, so for example, we want to add a step to pause, we can do that just by clicking Add Step and clicking on Pause. And then we're given a series of options for things like pausing until hold to resume, delaying for a certain amount of time, or pausing until a specific temperature is reached. You can also add a message to display. So if you want to prompt the user to, let's say, add a plate or prepare a reagent or something like that, you can always create a nice text message that will come up on the screen so that the user knows exactly what's going on through the course of the protocol. If you wanted to add a magnet step, you could do that here. The steps for a magnet step are pretty easy. So you're either going to be engaging the magnets, disengaging them, and then you can always set the height at which you want to engage based on the specific labware that you're going to be using throughout the course of a protocol. The last example here, we can add a thermocycling step. So in the thermocycling parameters, you can change things like the volume that's in the well that's loaded in the thermocycler. You can change the lid temperature, and then you can add steps and cycles based on whatever's determined by the kit chemistry. You can also do things like open and close the lid and change the temperature of the lid as well. Once you've built your protocol and created a series of steps, then you can see in the final deck state of the instrument all of the liquid handling steps that have been completed. So our protocol so far is pretty simple. So what you can see is that we have loaded reagent from the first well of our reagent trough and loaded it into the first 3 columns of our destination plate. And you can see now that our destination plate highlights in blue corresponding with our liquid color in the final deck state. If we were to add more liquid transfer steps, so for example, if we wanted to add sample to our destination, we could do that as well, and it would populate in this final deck state. So let's take a look at what that looks like. I'll add a transfer, and this time I'm going to use my single channel pipette to access my tubes that are on the deck. I'll select those here, and I'll select all 24 of my samples to transfer. I want my destination to be my destination plate and the 24 wells where I've added my lysis buffer. And this time I want to change my tips in between each transfer to minimize contamination risk. And I'm going to select single transfer because I'm just going to be doing 1 sample per well. I'm also going to add a mix after the dispense so that my lysis buffer is thoroughly mixed with my sample after my dispense has happened. I'm going to save that parameter. You can see that it shows on the left that my sample is going to be added to my lysis. And as I hover over these steps, you can see exactly what is going to happen. So you can see highlighted in blue on the work table that my sample is going to be transferred to my destination plate. And you can even see on the tip rack that the number of tips that are going to be used during the course of the protocol. All right, so that's the main technical overview of the protocol designer and sort of how to build a protocol. We're going to next move over to a few tips and tricks that we can discuss in terms of optimizing protocols or tips that you might find useful when using the protocol designer tool. I'm just going to also pause and remind folks that this is a good time to enter your questions into the Q&A, and we'll make sure that they get answered after we go through this tips and tricks section. All right, so the first tip that I want to talk about is going to be the batch edit functionality of the protocol designer tool. So you can see here that I have 2 transfer commands. I have the option of clicking Shift on my keyboard and then selecting those transfer commands in the software. And you can see that that initiates this batch edit mode in the software where I can change commands and parameters for both of the transfer steps that I have selected. So that can be things like the flow rate, the tip position, and then the other advanced settings that we went over earlier. Once you've selected the settings that you would like to batch edit, then you can click Save, and those changes will be saved to both of the commands that you have selected in batch edit. Batch edit is also a really good way to either duplicate or delete multiple steps at a time. So if there is a step that you repeatedly find yourself programming in the software, you don't have to create a new step each time you use that command. You can also use the duplicate function that you see here. If I click duplicate, then you can see that the two transfer steps that I have selected are now both duplicated. If I want to delete multiple commands at once, I can do that as well using the delete command here. Another useful feature is the note section of our commands. So you can imagine a command that instead of just saying transfer is a little bit more descriptive about what's happening in the step. Because you can imagine if we had maybe 10 transfer steps, it would be very confusing for a user to go back through each step and know exactly what's going on. So what I recommend is that when you're writing your protocols, you use the notes section. So once I click the transfer, there's a button down here for notes. You can see that our step name is transfer, but what we actually did in this step was we did a lysis transfer. So I'm going to call this step lysis transfer. I'm going to click save my command again, and then you can see on the left that it populates with the note that I left in the command. Then I can name this one sample transfer. Click save my command. And instead of a list of just transfers, I have very nice language around my commands so that anybody who looks at this protocol would know exactly what's happening at each step. The last little bit of information that I want to give you around the Protocol Designer is back in the File tab. So one of the questions that I probably get the most about this tool are around these three functions here. So the first function, create new, is fairly obvious. It's built so that you can create a new protocol from scratch. But if you don't want to start from scratch, or if you want to modify a protocol that you've already created, then you can click on import. And then you can upload a file either from your local directory, or maybe it's a shared network drive that everyone in the lab uses to create protocols. You can use the import function to import those protocols here. But most importantly is the export function. So the export function is a lot like the save button. There is no native save feature or auto save feature while you're building a protocol. So make sure that you export or save your versions of your protocol often. This is a web-based tool, so it does not save your protocols. So just make sure that you do that to your local drive by using this export function. The export function is essentially what will create your final protocol state. It will create the .json file that's needed to upload to the Opentrons app so that you can run a protocol on the actual robot. So with that, we've thrown a lot of information your way about this tool. So I am going to go ahead and conclude the presentation and open the floor up for questions.
All right, thank you for that, Catherine. Question number one that we've got come in is, do I need to be connected to an instrument to be able to run Protocol Designer?
Yeah, that's a great question. So Protocol Designer does not require the connection to an instrument to be able to run. So as long as you're connected to the web and can access designer.opentrons.com, then you can create and build protocols.
Great. Can you then subsequently simulate protocols?
Yeah, absolutely. So with our protocol designer tool, once you've exported a protocol, it can be loaded into the Opentrons app, and the Opentrons app will give a line-by-line indication of everything that will run in the protocol prior to a run. And this is a nice way to simulate or recognize what steps will happen in the protocol prior to a run.
Thank you. Third question is, can I edit my protocol after it has been exported?
Yeah, absolutely. So that is the import functionality of the protocol designer. So whether it's a protocol that you created or that a colleague created, it can be imported as long as it's in that .json file format and was created using the protocol designer.
Thank you. Is there a way to import from, so basically this is a cross-compatibility question between, basically are files from Protocol Designer and Python cross-compatible?
Yeah, that's a frequently asked question. And unfortunately, the answer is no. So Protocol Designer will only handle the .json files that are created using the Protocol Designer. It will not handle Python protocols that are generated using our Python API.
Follow-up question. This is module related. When using a thermocycler, do you have to use some sort of cover slip or overlay for thermocycling? Or essentially, how do you mitigate evaporation while using the on-deck thermocycler?
Oh, great. So with our thermocycler, there are a few ways that you can mitigate evaporation. So one, the lid of the thermocycler itself is heated. So you can set the temperature lid of the thermocycler. And then second is actually sealing the plate itself. So the Opentrons thermocycler does have a rubber gasket style seal that is present on the lid itself. And as the lid automatically closes, that seal will close against the top of the plate to seal the wells. However, we do also have users who will add their own seal to the top of the plate prior to closing the lid of the thermocycler. And the way that they do that in the software is in the design tab using a pause step. And that pause step, you can pause until told to resume. And then the message you can display to the user is add a seal to the plate in the thermocycler. Click save, and that pause step will execute prior to your thermocycling step.
Perfect. So all of these processes, are they occurring in a sterile environment?
That's a fair question. So the Opentrons robot is an enclosed system, but it's not a sealed system, and nor is it inherently sterile in any sort of way. So if you want to use the OT-2 in a sterile environment, we recommend either putting it in some sort of cabinet, where the user will sterilize the system before and after running, or we do have a HEPA module that's available. It is a positive pressure system that basically blows clean air over the deck. It doesn't inherently make the OT-2 sterile, but it does provide a clean air environment for working with samples.
Thank you. We're going to get back to more hardware and software questions, pipette related. Can you describe in more detail what tip, touch, and air gaps are?
Yeah, absolutely. So I'm going to click here back in our transfer command and open up my advanced settings where those live. So a tip touch is built for a liquid handling step where you might have a droplet at the end of a tip. So for my own personal example, if you've ever worked with PEG, for example, it tends to be very, very bubbly. And sometimes when you dispense, there can be a little bit of a bubble at the end of the tip. And so you can basically touch the tip to the side of the well after you've dispensed, and it will pull that bubble off of the end of the tip so that you can drop the tips to the waste without any risk of either the bubble bursting or dropping onto the deck of the instrument. Air gaps are really useful in creating a cushion for whatever liquid you are transporting. So if you think about liquids that tend to drip when you pipette them manually, air gaps are really useful in aspirating a little bit of air after you've aspirated the liquid so that the liquid itself is less prone to dripping out of the tip because there's a little bit of air cushion that sits underneath it.
All right. Can you ask the OT-2 to aspirate from a column that has got some wells that do not contain liquid? And how would you change the Z heights on those liquid on that labware choice?
Yeah, absolutely. So if the wells do not contain liquid, you can absolutely have the system still aspirate from them. That's not a problem. In order to change the Z height of the aspiration, we call that the tip position. So if you click on the tip position, you can see that you have this sort of prompt that comes up on the screen. The default is that the OT-2 will aspirate or dispense 1 millimeter from the bottom of the well, but you can adjust that in 1 millimeter increments using this tool here on the right.
All right. Next question is it this is an easy one. Is it possible for the liquid handler to do plating? How would you do that?
To do plating? Yeah, absolutely. So think of the OT-2 as essentially pipettes in a box. So any sort of liquid handling steps that you would do manually with a hand pipette, they can be executed on the OT-2. So if you wanted to, let's say, transfer this lysis or whatever region it may be to the entire plate, you can absolutely do so just by selecting all of the columns in that plate instead of just a select view.
Thank you for that. Next question is, can we prime the tip? Basically, the term I think you're used to is condition the tip before transferring a desired volume. Viscous samples may stick to the pipette tip if we do a single draw and release. So this is more liquid class centric. And for all liquid class related questions, I would encourage our audience to watch we have a very specific liquid class webinar. But Catherine, I think you're more than apt to handle this as well.
Yeah, absolutely. So along the lines of sort of this analogy of, a pipette in the box. So anything that you can do by hand, you can do on the OT-2 as well. So if you did want to possibly pre-wet the tip, that's an option. But to Mike's point, when you use viscous liquids specifically, we do have a really great guide and application note on exactly how to do that. And we'd be more than happy to follow up after this call to link you to those resources.
Thank you. Does the touch tip function you mentioned earlier scale with tube geometry, specifically with conical tubes, or is it absolute?
That's a great question. So when you build your work table on the OT-2, you will be using labware that matches the exact labware definition in the software, so that the geometry in the software is exactly the same shape and form as what you're actually using. So each of these labware definitions that are in our library contain that geometry information. So the idea is that when you do create a transfer step and you aspirate from a specific tip position, the instrument will know exactly where 1 millimeter from the bottom of that labware is, because it is accessing a very specific labware definition that has been created in the software with a very specific dimension. So if you do modify the tip touch, it is going to scale accordingly to the geometry that is set in the software.
Thank you for that. Is it possible to exchange pipetting tools during a run to adjust according to a pipetting need?
That is a great question. It is not. So the configuration of the pipettes is something that needs to be set at the beginning of the run, so that that information is stored throughout the course of the protocol. And also, once you're done with this protocol and it's uploaded into the Opentrons app, there will be sort of a calibration check that happens based on the length of these pipettes and the length of the tips. And that calibration happens prior to running a protocol, and it's not a current capability that can be modified in the middle of a protocol. So what we would recommend is that if you have a step where you need to change pipettes, you have one protocol for one configuration of your pipettes, and then a second protocol that uses the second configuration of pipettes.
Thank you for that. Next question is it possible to assemble a PCR reaction directly in a plate that is located on the thermocycler to avoid the need of transferring the plate to and from the thermocycler?
Exactly. That's a fantastic question. So the answer is yes. So what we can do is we can add a plate to our thermocycler, and we can call this PCR plate. And then we can create a series of transfer steps with master mix, whatever it may be, into this plate. And both of the pipettes that are mounted on the gantry can access this plate. So you can do a full suite of pipetting steps into and out of this plate as it sits on the thermocycler, so that no user intervention is required if you want to use this module.
Thank you for that answer. I would like to remind everyone, we're only going to answer about 2 to 3 more questions, but if your question does go unanswered, we will have someone from Opentrons reach out to get you an answer shortly after. Next question is, does your company PM or do preventative maintenance on the instruments periodically to ensure pipetting accuracy? And do you have preventative maintenance protocols in place?
Yeah, that's a really great question. So Opentrons operates on sort of a customer enablement model where we encourage our customers to take the sort of care and maintenance of the instruments into their own hands. And so we have a full preventative maintenance guide that we can provide that was built by our support team. And it serves as an excellent source of documentation for how to care for the instrument and how to check things like accuracy and precision. Mike, you are muted.
One day I will learn how to use Zoom. If I have a variable number of samples, can I adjust the protocol at runtime in Protocol Designer to only pipette the positions that I hold, that are holding samples?
So that is not a current functionality of Protocol Designer. What I would recommend instead is that you have multiple protocols based on different sample numbers. So if you run, say, 48 samples and 96 samples, and those tend to be the 2 sample configurations that you run, then I would recommend that you have one protocol built for 48 and one for 96.
All right, thank you for that. I think that'll be the last question. Catherine, if you want to flash up our contact information, that'd be splendid. Again, if you have any questions or concerns about what you heard about here today, please do not hesitate to reach out. Thank you all again, and I look forward to seeing you all in the future in other iterations of our webinar series. And please feel free to go back in the library and look at past webinars. A lot of questions on API and other topics that we've addressed. Take a listen. Look forward to hearing you all for the future and hearing from you all in the future. And thank you for your time. Have a good day.